Number 20 asks, what is the radius of the following circle if the arc length of, this should be AC, is 2 pi centimeters? So it's asking us to work backwards a little bit because it already gives us the arc length. We know the arc length will be 2 pi equal to the fraction of the degrees times circumference of the whole circle. So this will be 120 out of 360. So we've got 120 degrees out of the whole 360 because that's what relates to arc AC. And that will be multiplied by the circumference formula, which is pi times the diameter. So in order to get rid of or to move this fraction away so I can solve for the diameter, I can multiply both sides by the reciprocal, 360 over 120. If I do 360 and I multiply like this, we can find the common factors and we can reduce it down, and that would end up being 1 times 1 over 1 times 1. So here we've got this, and then 360 over 120. So then when you do 360 over 120, you end up getting that this comes down to 3. So if I rewrite, I have 3 times 2 pi equals pi times the diameter. So 6 pi equals pi times the diameter. If I divide both sides by pi, I get 6 equals the diameter, and half of the diameter will be 3. Number 21 gives you the area of a sector and asks you to find the radius. So let me move this down just a bit. We will do the same thing where we know already what the area of the sector is, which is 22.5 pi. For right now, I'll leave the units off. Oh, one moment. Let's go back. This should be 3 centimeters. There we go. Okay. I'll leave the units off until the end. So this is equal to the fraction of the angle, or the angles, excuse me, which is 100 over 360. And since I'm working with area, that'll be multiplied by the area of the whole circle, which is pi r squared. In order to get rid of, or to help get the radius squared by itself, I'll multiply both sides by 360 over 100. 360 over 100. So the way I would do that in my calculator, I would do 360 divided by 100 times 22.5. Now I'd get 81. So this side needs to be 81 pi. 81 pi is equal to pi r squared. If I divide both sides by pi, I get 81 equals r squared, so the radius must be 9. For number 22 and 23, we are going to be using the volume formulas. You will have the blue sheet that has volume formulas on the test. You just need to know how to use them and how to plug things in. So if we're dealing with an oblique rectangular prism, then that will be length times width times height, or the area of the base times the height. Anything with a capital B is the area of the base. So if it's sitting here, we'll do the area of the base times the height. So either way, it works out the same, where we'll be doing 3 times 4 times 6. So we get 72, and it tells us that all measurements are in inches, so inches, and if we are talking about volume, that will be cubed. Cavalieri's principle told us that if the area of the base is the same all the way up, or I'm sorry, if each cross-section area will be the same as it was standing straight up, then if it's oblique, we are good to go. And we can use the regular formula. Keeping in mind that this right here is not the height. That is the slant height and will not be the same as the height. It will be longer. So don't use this. If we ever give you this, it's a trick. Don't fall for it. Number 23. We are going to do the volume formula for a cylinder, which is pi r squared times the height. Pi r squared being the area of the base times the height. So this is technically also area of the base times the height. All we need to do now is plug in what we know. They tell us that the radius is 4, so we can say 4 squared, if we plug it in here, gives us 16 pi times the height, which is 10. So we should get 160 pi inches cubed.